Hello, everyone. Welcome to Backyard Musings, broadcasting live from Apple Valley. I'm Steve,
I'm Scott.
and together we are Backyard Musings. We are the science and technology channel. We bring you science and technology, hopefully, give you hope for the future, cutting edge stuff that's happening. All right, here's my spiel. In Perspective, published on November 13th in Intelligent Computing, a science partner journal argues that modern artificial intelligence systems have fulfilled Alan Turing's decades old vision, which is this: machines capable of learning from experience and engaging in human like conversations. Authored by Bernardo Gonçalves, a researcher affiliated with the University of Sao Paulo and the University of Cambridge, the paper examines the alignment between contemporary AI technologies and Turing's ideas while highlighting key differences. Would you like to know more?
The paper emphasizes how today's transformer-based systems, despite their significant energy demands, contrast with Turing's concept of machines developing intelligence naturally, akin to the learning process of human children. Gonçalves notes that transformers, which power current generative AI models, provide what Turing described as adequate proof of machine intelligence. I don't know exactly what that means. Maybe you can elaborate on that. So, leverage attention mechanisms and large-scale learning. These systems now excel in tasks traditionally associated with human cognition, such as generating coherent text, solving complex problems, and engaging in discussions about abstract concepts. So
that's the explanation right there.
Okay.
This AI is doing that now, and we have adequate proof of that.
So there's that thing. I think it's called Chat GPT.
Chat GPT.
So I remember hearing about that a while back, where a college student, let's say, needed to do a term paper, and they just Chat GPT just a little bit of information, and it'll take it and run with it.
But you got to understand, the Chat GPT is like a child. It doesn't have the wisdom of piecing together stuff if you're trying to write a paper, you know what I'm saying? So it might have some faults, because looking at everything on the internet, it might have some false premises, which you need to catch as the human, and adjust fire on that.
Okay, but from what we just read, though, or just talked about, is it going to be able to mature? And the longer it does it?
Well, we hope that it doesn't become self-aware, because when that happens, then that's Judgment Day.
The machines will take over, huh?
Yeah, the machines will take over, man, and they'll know how to kill us. So let's just hope they don't become self-aware. They get smart to help us, but not self-aware.
I'm not laughing. That's funny, that's for sure.
Okay, so, quote, without resorting to pre-programming or special tricks, their intelligence grows as they learn from experience, and to ordinary people, they can appear human-like in conversation, writes Gonçalves. This means that they can pass the Turing test, and that we are now living in one of many possible Turing features, where machines can pass for what they are not.
Okay. This achievement traces back to Turing's 1950 concept of the imitation game, in which a machine would attempt to mimic a human in a remote conversation, deceiving a non-expert judge. The test became a cornerstone of artificial intelligence research, with early AI pioneers John McCarthy and Claude Shannon considering if the Turing definition of thinking and Turing's strong criterion. Popular culture, too, undeniably reflects Turing's influence. The HAL 9000 computer in the Stanley Kubrick film 2001: A Space Odyssey famously passed the Turing test with ease. So, I remember when this movie came out, and I want to say it was in the 80s, maybe 70s.
Yeah, late 80s, maybe middle 80s.
Yeah. Anyway, of course, we're way past that now. So
Yeah. So, however, the paper underscores that Turing's ultimate goal was not simply to create machines that could trick humans into thinking they were intelligent. Instead, he envisioned child machines modeled on the natural development of the human brain, systems that would grow and learn over time, ultimately becoming powerful enough to have a meaningful impact on society and the natural world, and to wipe out humans systematically. I added that last sentence in. But I mean, it's if these things are going to grow, you can't. There's no like switch that you can, or like a capacitor thing that you can limit or dumb them down to a certain point. They're going to grow and grow, and this growth is not going to stop. And the natural man is prone to sin, is prone to steal and lie and kill and covet, and that's what machines will do too, and they'll do it perfectly,
yeah.
more efficiently than we could.
Well, and I find it funny that they're talking about creating a machine. I know plenty of people who think they're intelligent. They don't have any access to a machine. So, yeah.
Is that a dig at me?
No, not you. But I know. I mean, I know a lot of people who think they're pretty smart. So, but all right. So I'm up, right?
Yep.
The paper highlights concerns about current AI development. While Turing advocated for energy-efficient systems inspired by the natural development of the human brain, today's AI systems consume massive amounts of computing power, raising sustainability concerns. Additionally, the paper draws attention to Turing's ahead of his time societal warnings. He cautioned that automation should affect all levels of society equally, not just displace lower wage workers while benefiting only a small amount of technology owners, or small group of technology owners. An issue that resonates strongly with current debates about AI's impact on employment and social inequality. Now, I know today, if you go to a certain fast food restaurant that has some golden arches for its signature sign.
I can smell it right now. It's on the breeze right now.
Is it?
Oh,
Yeah. So you don't even hardly talk to people there. I mean, you got to flag somebody down at the counter if you want.
Give me the code to get into the bathroom. Yeah, you got to flag them down.
Yeah. So, but I'm telling you, I'm not at that point where I'm comfortable ordering at a kiosk, especially if it's a large group. I mean, and I'm not one to go to that particular restaurant and modify my meal. I mean, I learned that a long time ago, probably 40 years ago. If you want to wait in that particular restaurant, modify your sandwich or order something special, and it just throws everybody off into a tizzy.
Yeah, like no pickles or no mustard, yeah.
Or no onions, yeah, or whatever. You gotta be aware of that. But anyway, I don't think. Go ahead.
Regarding what you said about a massive amount of energy required, the going back to the Terminator series, that they solved that problem by having a little nuclear pack that was put into that powered the Terminator for 100, 200 years, 140, 200 years. So
is that why they were so hard to destroy?
Well, I mean, the chassis, the steel chassis that was on, well, that was hard. Hard to get through the chip. It's surrounded by all that metal. And they could kill you so easily. I mean, they could just smack you and break your neck. So having the munitions. I'm going into theoretical here. Having the munitions to destroy that metal, to get to the chip and destroy the chip before they got to you and ripped your throat out. I mean, yeah.
Is it worth it?
So looking ahead, the paper calls for Turing-like AI testing that would introduce machine adversaries and statistical protocols to address emerging challenges such as data contamination and poisoning. These more rigorous evaluation methods will ensure AI systems are tested in ways that reflect real-world complexities, aligning with Turing's vision of sustainable and ethically guided machine intelligence. And by poisoning, I don't think he means like a physical poison that kills someone. I think it's like a thought, the machine thinking the way we don't want the machine to think, like dismembering us. That will be contamination, poisoning.
Try thinking it's going to take over when ultimately a machine eventually is going to need some kind of a tune-up, right? And who's going to give it a tune-up?
Well, if the other machines get together, they can tune each other up. You know what I'm saying?
You think they've got that capability to do that?
Right now, no. Right now, no. But if they get into a collective type thing where you got a boss machine that can direct minion machines, yeah.
Yeah, I've worked for a few of those too. So, okay. All right.
All right, folks. Yeah, very interesting topic. This has got to be addressed. With AI, AI is helping us a lot, but it could turn on a dime if machines become self-aware. Really could.
Opposition in all things, right?
Yeah. All right, folks. Thanks for joining us. We'll see you in the morning.
Take care, everyone. Thank you.